Hi everyone, it's great to see you see almost everyone in here. So I'm very happy to be here with you today. And I hope that everyone had a nice evening and morning. Yeah, I had. So yeah, cool. So for some time I've been thinking like how code relates to product and what role it plays. And today I would like to share with you my findings. But before we dive into that, I would like to start with a question. Who of you thinks that code is important? Please raise your hand. Okay, cool. Not everyone. That's promising. But we'll get back to that later on. So quick agenda. So the talk is divided into four main parts. Firstly, we'll discuss broader context of code. And then I will briefly tell you a story of the product that I'm currently working on. And two last bits, building vision, growing structure, will be about how we build products and what we call a product-driven framework. So let's begin with context of code. So we're not hired to just write code, okay? We're hired to solve real-world problems. And let me give you one example of that. So some of you might recall that in 2014, in April, there was major outage of 911 emergency number, and calls got stopped getting dispatched because of counter overflow. So once counter reached its max value, the calls were supposed to get a unique ID to get dispatched to a proper local unit, but they couldn't be because, well, there was a counter overflow, and the software actually did what it was told to do, but it was told to do the wrong thing, and yeah, that's why it failed. And it actually affected 11 million people, but nobody died, so good thing. And Nancy Leifson from MIT believes that we as software engineers don't understand the problems that we are trying to solve, and we don't care to, but we should, because every line, so code always exists in a product context, and every line of code solves a particular problem. And it goes even with open source software, right? Because what usually happens, and it happened to Rails, which got pulled out from Basecamp, it happened to RX, which got pulled out from Netflix. So that happens even to open source software. But what is a product? Product is something, anything actually, that can be offered to a market that that might satisfy a want or need. So, and this is important because customers pay for the value that product delivers to them. And product gets money from them eventually, even if it's an early stage, and investors pay for it because they hope to get more money back once customers start paying. So that's how we actually get paid for our job. That's how software engineers get paid. And again, the same happens for open source software, right? Because engineers are the customers, and they express their support through stars on GitHub, and certain projects get more and more popular. And then they might hope for corporate support, like the things that Nick was discussing before. Unfortunately, he's not with us, I guess. Tough night, yeah. So they can also benefit because people from the open source community, they help to build and shape the ecosystem around. So it's not only about money, okay, but also about like benefits that can be provided. So it's great to rewrite your code and make it cleaner, but actually that's not the point. How many of you know Joel Spolsky? Okay, cool. So for those who don't know, he's the guy who created Trello, and he writes on software, Joel on software blog for, I don't know, 10 plus years. Now, so the main point he makes is that we shall reach beyond code. We should think about problems we are trying to solve, because we're hired to build and ship products. So having said that, we can swiftly jump to the brief story of a product that I'm currently working on. So let me tell a bit more about it. So it's organization map, that's how we call it. And it started with a simple question. Like, we were interested and kind of wanted to sketch out what's going on in the company. I guess some of you might have the same problem. Like, do you know what's going on in your company? Like, what are the activities that are undertaken, what the company is doing? How many of you know that? Okay, some of you, cool. And we should all be kind of on the same page. So we should be aware of the wider context within we operate, not only on the project level, but also on the organization level. And actually, the answer was given for the very first time as a A4 PDF. so we wanted to make it printable. It was like 4 or 5 years ago, I guess. But at some point, it became difficult to edit that. But let me stop here for a minute. So what you can see are the main areas that were identified within the RailsWare organization. So, and underneath those, there are listed activities within those areas. So that was our first attempt to kind of sketch out what we are doing as an organization. But the next iteration was way more easy to edit. Yeah, it might be slightly strange, but we did it with a spreadsheet. You might ask, why not database? Because spreadsheets gives freedom of data blending. They give calculated properties, and you can reshape the structure as you go. So you don't have to deal with migrations, models, all of that. You just put data in a spreadsheet, and then you can reshape it as you go, as you need. But at some point, the more data you put there, the more kind of models you need. So you need associations. You need to somehow connect the entities together. And it's kind of tricky with spreadsheets. So at that point, we moved those spreadsheets to something that looks like a spreadsheet, but actually acts as a database. It's called Airtable, and it allows us to keep and maintain the freedom of changing the structure. So we could still change the structure on the go while having those calculated formula-based properties. And then we could like reshape those models, start to structure the entities, because we could easily connect them together in a very nice UI. But we started to ask ourselves, what's the best way to render the structure of a company? Like, what's the most expressive way? And this is actually, folks, the very first time when we publicly show this. So no one has ever seen that before in public. And I believe that this is the very right place to do it, because we, as a Ruby-oriented company which origin are here in Kiev, I guess that's a very good place to do that. So we did run, like, it's not like the first stage, right? It happened after 4 or 5 years of development, part-time. So this is more like current state of affairs. And we did, to get to this point, we did a whole bunch of experiments. Like UI-wise, we were trying with different kind of approaches to render those things, with colors, without colors, how to place them, what are the relationships between them, what kind of types of nodes we need, and so on. So it's started as a pure JavaScript plus jQuery. Simple applications served by Sprockets and Sinatra. So we didn't even start it with Rails, we started with Sinatra. And this way, we could learn that tree is better than any other representation. Like, you can immediately see that we have like five these days. We have 5 main areas of interest of what's going on in the company. But then the more people started to use that, we realized that it would be nice to know what people are actually interested in the most. So we have added a single action to the backend, so to the Sinatra backend, and we used SQL, not Active Record. And you might ask, why not use Airtable for that, since we use it as a database? Well, we didn't have permissions. We didn't have users at that point. So we didn't want to deal with user access to Airtable as well. And we didn't want like too many people to work and access Airtable because we were trying to reshape, like we were trying to find the right shape of data. So we were constantly reshaping that. And if too many people started to edit that, that would be a problem. So it was actually simpler to store it directly in database. So who thinks this is strange? Please raise your hand. Okay, I was expecting that more people would think it's strange. That's cool. So the trick is that often you don't even need to write code to experiment and validate some ideas. So what we did is we leveraged existing services for the sake of product development. So we could make experiments without writing a whole bunch of code just to verify if this makes sense. And we used like existing services like Google Spreadsheets, Airtable, and we closed the feature loops. Like up until today, we also use spreadsheets to kind of export data, to blend data, and then to upload them back to the system. And that's how we actually built the product eventually. So The approach that we use here is, I don't know how to do this, so let's do it the simplest way and we'll figure out. So we did experiment a lot because we did want to avoid building something that nobody wants, because this is the biggest source of waste in new product development, and we should avoid it at all costs. So what's the cost of doing all of those experiments? So after 4 or 5 years, we have accumulated $50,000 of tech debt. Do you think it's a lot or not really? Not really, yeah. So we believe so as well, and we're very happy about it because we embraced it to learn a lot through experiments along the way. And according to Code Climate, actually this is 12% of our code base. So tech debt constitutes 12% of our code base. And imagine how long it would take to do it the right way. And how would we know how right the way would be? So imagine also how wasteful it would be if the product turned out not to be wanted at all, and we would have to shut it down. So this approach allowed us to shape the further vision of the product. So let's talk about vision. It has to build constantly, because product is a never consistent set of features. Things are separate but work together. It's not like a single piece, well, in code base it might be monolith, but there are actually moving parts. It's not like a big chunk of things. Example, most of the products have authentication, they have user profiles, they have domain-specific concepts, and there is some glue code which brings them together. So we shall think of feature components because they serve as common vocabulary, common ground to facilitate the communication between engineers and non-tech people. And this is like very good for improving communication and also discovering the domain concept. So in case of org map that I have shown you before, there are things like map, my view, filters, and resources. So those things can be actually splitted. So if we look at the big parts in the middle, those are like those big, bold features, like for example, the map view. But then we identify pieces within it, like filters, my view, and so on. And it can grow as a structure indefinitely. So this is very nice way, very nice example of divide and conquer approach that we are all familiar with. So the idea is that we shall have as much vision as we can. So we do it as a product group. We don't do it as individuals. So we always try to do it in a collaborative way. So we identify what is short-term, mid-term, and long-term, and it's based on current knowledge. So it will evolve over time. So we will definitely start with short-term and then go as far as we can. The more we see, the more long-term it is, right? So we do it for each component, which of those violet things that I have shown you before. And when you start, it will look like this. You will see not very much, I would say, and the black part can be described as uncertainty. So those are the things that we don't know. So we know very, very little. But then we can make educated guesses as a product group, product team. And those are the things that we think that would be good to do. And this actually allows us to experiment. So we need to validate hypotheses with experiments. And not all of them will turn out to be right. But as Thomas Edison once said, I haven't failed. I have just found 10,000 ways that won't work. So this is also beneficial. And at some point, we'll naturally start to see what's coming next. But we might be wrong. And actually, at some point, we might need to refine the vision. And this yellow part is what we identify as tech debt, but it might be also product debt and design debt. So for UX, it will also apply. And this yellow part is actually what will hold you back. But after doing enough experiments, you will reach midterm. And one of examples when it might happen is that customers start to ask about features. They start to ask for features, and they say they really need that. But be careful with that, because remember Henry Ford, who was the first guy who made an assembly line for cars? Yep, he said that if he had asked people what they needed and what they wanted, they would get faster horses, but he made cars. Because what they were really after is comfortable and fast transportation. They just couldn't imagine that. So one example of that comes from one of our own products. It's the smart Jira checklist add-on for Jira. And actually, customers were asking for resetting statuses. But what they were really after were templates for checklists, because they wanted to reuse those checklists over and over again. So they mentioned resetting statuses, they wanted templates, and we had to kind of identify that need. And what happened is that they found a way to achieve it. It was what we call combined features. So they did leverage the Markdown editor that stays behind this nice-looking checklist, and they exported it as a text to Evernote. They have created a repository of templates that they could have later on reuse over and over again, importing into another place. And such things should be refactored on the product level first, not the code. So depending on the resources, you might show certain parts, certain feature components to different people. And then you can measure what's changing. So if they say, I like it, but maybe if, the things that are changing will remain midterm because someone needs that, but not like everyone or not all the personas that you might have identified. But those things that are the same become long-term. And this is actually something that we all hope to reach, right? Mount Doom in Mordor, yeah. And this is actual customer validated stuff. So the more usage there is, the more long-term it becomes. So it will stay for longer if more people use it. So we shall measure traffic, where people go, what they use, and this will be long-term. So having vision allows us to grow the supporting structure. Yeah, minute for a photo. Okay. Moving on, thank you. So grow only as much structure as it's necessary to support the current product vision, and no more, because that would be terrible waste of time and money. So the moment we start thinking about value provided by a product, we might also describe good code as the one that provides highest value for the lowest cost. But value might be different in different contexts, right? So you will write slightly different code if you want to just tinker and play with features and look if they make sense and experiment a bit. And you will use a very different approach if you, I don't know, want to scale your application for 1 more million of users. So value might be different, but you can ask one universal question whenever you work on code. What's the goal of that code? So what purpose does it serve? Because writing and changing code is expensive, so we should kind of have that in mind. So how can you know that? Every now and then, we need to assess tech compliance to vision for each component. How it complies to the vision and how it supports it, and how it supports its growing. So we gather tech leadership group. Again, not a single person, not an individual, but in a collaborative manner. So make decisions as a team, as Duana mentioned yesterday. And look at architecture for each component to see that. Because things might have changed over time. So some experiments might have proven to be right, some might have turned out to be wrong. And that needs to be reflected here and assessed. So the general idea would be, for the sustainable development, would be to increase the code quality and structure rigidity as you head towards long-term. So that means that we shall grow abstractions as we head towards long-term. So again, starting for short-term, you build only what you need to support the experiment. So the structure shall be very much experimental. And why is that? So because likelihood of unanticipated changes is huge. Like we don't know. We try to find out, right? So it might change in a very unanticipated way, and well, we don't know yet. We try to figure that out. So there is no point to do more than necessary to find the answers, just the bare minimum. But as you go farther down the road, you need to improve the structure because you kind of suffer from its inflexibility, you suffer from this well, weird code. So we need to clean up after experiments, and we need to reflect acquired knowledge into code base, because the more understanding we get, our code should reflect that to reduce the tech debt, so that you can move on and start new experiments, because it's like never ending. So some components might become long-term, but on top of that, you will build some mid-term components and then also short-term components. So you might also have like short-term experiments on some more like rigid things, and then you can like improve those structure and separate those things that are going to change. So when you go long-term, you need to stabilize as much code as you can, because that's how our brains work. So we have like limited capacity of what we can achieve with our brains, what we can hold in memory. And that's why we create abstractions. We create abstractions to name concepts, not to always think about nitty-gritty details, like implementation details, but to have a single name to which we can refer as a group that will like name the behavior and explain the behavior that's under the hood. So that's why we should aim to stabilize as much code as we can. And there are actually different techniques. The one that I found interesting is based on social analysis, behavioral analysis on the repository. There's a tool called CodeScene.io. It works in a way that analyzes what changes in which commits and tries to group them together. And this is a very nice approach, because it can show that you have packaged together some code and encapsulated it within a single module, but some bits of it keep changing, and some of them are not changing because they became long-term and they don't have any need to change. So it's a clear sign that those things should be reshuffled and rearranged. And also verify when it will die. Well, it sounds scary, but it's actually about seeing growth and current usage. So it's about scaling cost of infrastructure, for example, like some N+1 queries. Just be aware when it, well, might collapse, so to say. Or talk to Charles about JRuby. That's an alternative. So one example of that, we're doing small migration in Mailtrap. Anyone heard of Mailtrap? Cool, some folks. So for those who didn't, Mailtrap is a fake SMTP server for development teams to test it on staging and production without spamming real people. And as part of that, it's somewhat like Mailcatcher. And there are some long-term concepts. One of those would be messages and inboxes and attachments. Like it receives emails, we call them messages. Emails might have attachments, long-term thing. And we are still storing attachments and messages entirely in database. And that's, yeah, that's not very good. And actually that's, that makes up 85–90% of our database usage. So the database keeps growing and growing. And we need to address that, because those are the long-term concepts, and the infrastructure is also long-term for that. But we need to kind of reduce the cost of maintaining of that. So the idea is to move to S3. So the API might slightly change for folks who use it, but no a big deal. Not as big changes in Trailblazer, fortunately. But yeah, just bear that in mind. So having said all of that, how we can do it sustainably? So the answer is to always maintain reasonable code quality for everything. And you might ask, okay, so shall we do some shitty code for a short term? Well, most likely yes, because we shall not overspend time and over-engineer things that we might just throw away in the next week or the next day, because, well, that's the sort of experiments that we do. But if you like lower the bar to low and you don't clean up after experiments, you will suffer from low quality of code, because, well, that's the funny trick. If you try to speed up development by reducing the quality of code, it will like slow you down eventually even more than if you have invested into that before. So one example, code without tests is harder to refactor because you don't know if it works as intended or not. And I found an example that if you tell your managers, do you want a feature that is working now but might stop working the next week, would they give you more time to write tests to ensure that it will work or not? Well, I believe they will. So another point would be about inconsistency in code styling. So a quick win would be to configure tools like Robocop or ESLint to just have consistent code styling, because inconsistency triggers brain, and that actually raises costs without providing any benefits at all. So I would say that the bare minimum would be to configure those, write some preliminary tests, and establish continuous delivery. Because it's a quick win, like automating processes is always a quick win. Maybe not that quick, but definitely a win. Because that lets you focus on things that matter. Because you want to support process of changing product and code. So automated way will help you with that, because you wouldn't have to think about all of that. There is a great practical guide, like some folks were recommending some books, I will recommend one too. So there is a practical guide to writing cost-effective, maintainable, and pleasing object-oriented code, but some of the aspects can be also applied to functional programming and other paradigms. And also the TDD is quite nicely described there. And the authors of the book also referred to Martin's Fowler refactoring book, which is worth reading. So I don't want to dive too much into that, especially after yesterday's talk about growing architecture and so on, but I will leave it so you can read it if you like. But I will give you some hints. So, yeah, not too much, but just a bit. So thorough PR reviews can help improve the code quality. Spread knowledge and also understanding of a product among engineers, but only if they are done right. So that's the trick. So how can they be done right? So whenever you open a PR, start with self-review before you ask someone else. Try to get this slightly more distant perspective to the code that you have just written, and try to look at it from more like product-like perspective, from the reviewer perspective. So try not to think like what you know and what you have just implemented. Try to think about the wider, broader picture of it. When you review a pull request, on the other hand, you should focus on things that have not been automated. So if you configure Robocop and ESLint and all of that and tests, you know that things work or not. But there is, well, as far as I know, there are no tools that actually can spot if the naming is correct, if the name complies to domain concept naming, and if the abstractions are right, or if the code is compliant to the vision, or is it in the right place. So those kind of things are the points that are worth looking into during the PR review. And funny thing that we have noticed is that if you don't look at code from the perspective that you would work on it the very next moment, like you would take it over, then you look at it, okay, maybe it's fine, maybe not. I don't really care because I will not work on it, right? So you have this more like distant approach. But when you think, like when you have this mental model that you might need to jump into that code right away, you will focus more and more and try to understand it deeply, really deeply, because, well, that's what we need to work on code. We need to understand it. And the fun fact is that, well, maybe not fact, but the fun thing is that author and reviewer equally are responsible for code quality. So it's not only the author, it's also the reviewer responsibility. But growing products in an iterative way inevitably leads to a tech debt, because we acquire more knowledge, we don't have like full spec of requirements, they might change over time, and bunch of incremental changes will collect over time and actually produce like patched together code which is inconsistent. And to sustain development pace, it's important to reduce it towards the vision, so it doesn't hold you back too much. You cannot avoid it. Well, if someone can, then talk to me afterwards. But, well, most likely we cannot avoid it. But what exactly is a tech debt? Most of us refer to it as a to-do and fix me, but actually it's any kind of inflexibility that holds us back. And it's, well, tech debt is specifically about code, but as I mentioned, there are other kinds of debt as well. So it happens when actually code and structure and abstractions no longer express our mental model and current knowledge of the product team. And they don't support what product is heading towards, right? So it can manifest itself as rigidity, inflexibility. So you will find some changes more difficult to make than others, and that will be tech debt. So it comes from learning, but it also comes from conscious decisions. Because you can cut corners in one aspect over another, like, for example, to support experiments. So it might not be inherently bad, because, well, usually we think that tech debt is bad, but actually there are some good aspects to it, and not every tech debt is bad, because if, like, the best kind of tech debt is that might never come due. So this is when you start a new product, you do some experiments on it, you do it a quick way, and then if it works, then cool. If the product will hit the market and users will love it, then perfect, you can clean it up. But if not, then no hard feelings, right? We won't suffer from this tech debt. So it's kind of a trade-off that sometimes it's worth taking. So how to deal with that? First things first, so it's vital to, like, make everyone on the same page. So to make it transparent. Usually what product managers and project managers see is that, like, some developers who are not very happy about the project, code quality, and so on. So I would say that this is the 10% above the water, but there is actually a lot going down there, right? The remaining 90%. So use tech debt as it's a nice metaphor. Like, every one of you and non-tech people will understand what is a financial debt, right? It has interest rate and so on. So we shall use it as a metaphor because it really works. So how we do it, we create tickets in product backlog. So whenever we encounter code, it usually happens during PR review. We discuss it and we see, okay, that might not really reflect our vision, that might not really be very good. So we identify the tech debt together in a collaborative way, and then we create tickets. So they will be later on in the product backlog next to feature tickets and some bug fixes if needed. So actually, automated tools can help you with that, because everyone loves chart, everyone loves, like, numbers, colors, and so on. So tools like Code Climate, for example, can help you with that to reveal trends. They will not provide you with an answer if it's good or bad, because it depends on organization, project, and so on, but they will give you a way to see the trends, like if it's growing or not, because the biggest risk is if it grows too much, because it tends to accumulate over time. So charts like complexity versus churn can actually help identify the most troublesome places. And as I mentioned, not tech debt might be important. So not tech debt is created equal, right? So if a given feature is rarely modified, then it will definitely have a lower tech debt because we don't look into that. It doesn't slow us down. It doesn't cost us energy and focus, right? So there is this trick from Toyota factories, the process of asking why 5 times to identify what are the problems. So it's a step-by-step approach, Kaizen-like. We iteratively acquire knowledge, try to understand what happened. Example for that would be that, let's say that we have deployed bad code and the production is down, right? I'm not saying that it happened to me, but it might have happened to someone. So the case that I have seen was actually caused by an infinite loop. So it just used all the resources and then died. And then you ask question, why it happened? Okay, infinite loop. Why it reached production? Because we didn't have tests, or I don't know, this part wasn't covered with tests. Why it wasn't covered with tests? Okay, because the new guy doesn't know how to write tests, doesn't know our pipeline, and so on. So you try to understand what happened at those levels, going deeper and deeper, and then you improve processes, you expand the regression suite, and then you make proportional investment to address those problems. And actually, this is like a convergent process, so those problems will go away really, really quickly. So while creating tech debt tickets, we use both feature components and tech debt components. Because usually what happens is that you start with a single tech debt component, but then as the product grows and grows more and more, you can identify certain parts of code, and this structure might not reflect, it doesn't have to reflect the feature component structure. because, well, you might say, this is front-end problem, this is storage problem, this is some intermediary backend problem. So what we do is that we group tickets into epics on per feature basis, feature component basis, including not only feature tickets, but also tech debt tickets. So we work on them together as epics. So it's like understanding the desired change, making code open for the change, so we address the tech debt at that point, and then we introduce the change, which is usually easier. So we all know that whenever we work, at whatever we work, we shall leave the place better than when we got there, right? So it should be more clean than before. So the question remains when to do it. So what's the balance here? And our rule of thumb is that when it's in a place where you make changes and it's easy to fix and quick to fix, then we usually fix it because it's a quick win. But otherwise, we don't overstress ourselves and create tickets to address that later on, because they might be a better time to do that, and there is no point in distracting ourselves. But it's good to have this input because we make the tech debt transparent this way. So do not refactor without vision, because it wouldn't make sense. It's like overgrowing the structure without having the vision. So be driven by the requirements that change, because when the requirements change, code needs to be adjusted and extended to address those changes. So it will grow itself kind of organically. So prefer just-in-time refactoring. Don't do it prematurely, because you might waste your time, unless it's a quick fix, right? And ask yourself this: what is the future cost of not doing it now? So yeah, if the problem is solved, you might leave it or you might refactor it. So when you do refactor it, you might pay the opportunity cost of not working on something else which might be more important, like the coming release or something. So specifically, coming requirements will tell you how the code should change, which you couldn't anticipate before, right? So wait until you have the full information. Don't prematurely reach for abstractions, because getting wrong is easy, and code becomes convoluted, confusing, and costly, right? And your peers will hate you for that. But choosing well is hard, and code, when it's done right, it's expressive, concise, and nice to go through. And one of examples here would be that logic duplication is actually a sign of a hidden concept. So isolate the concept and name it. But having said all of that, tech debt, refactoring, the balance between those two, when you build experiments on top of experiments, at some point you might reach a stage when you don't have enough flexibility. And it's okay. And then you address that and you introduce the changes. So we started with the map. It was jQuery, right? But we saw that the more experiments we make with filters, with MyView, with reorganizing the content, ordering, sorting, and so on, we introduced more and more bugs. So we had to address that. So we needed to make a better structure for that. But at that point, we understood how it should change. So we didn't do it like prematurely. We did it at the moment when we had the full information. So give yourself enough flexibility, but not too much, because the more abstract the code is, the harder to understand it becomes. So we started with Sinatra, SQL, Sprockets, and jQuery. Right now we're running ES6, React, Redux, Rails. Not fully Rails, but almost there. So at some point in time, we had a strategic discussion. What is the solution direction for all of that? Like, which technologies would support what we are trying to achieve? And then we gradually moved towards that. And this is like an ongoing process. We didn't like stop entirely development on the features just to fully rewrite from jQuery to React. No, we started like piece by piece, component by component. And the same happened with Rails. We actually had like 10 to 20 different branches dealing with that step by step. So solution direction in this case would be high-level architectural and framework decisions, like the one that mentioned yesterday by Duana. So to wrap it up, so reaching beyond, like you shall reach beyond code and think about how those things fit together into the product and what is the value, actually. So think about the value. And use product vision as a guidance for code. So you will think a bit differently about experiments, and you will think a bit differently when you prepare your application for another million of users. So optimize for understandability. So the less abstractions, kind of, the easier it is to understand to some extent. And let those abstractions emerge naturally. So when they will insist upon being created, then you will know, and then you will have the full information how they should be shaped. So it's better to postpone it rather than having to deal with wrong abstractions. So when you feel the inflexibility while working with the code, it's fine. You just need to address that by making tech debt transparent. And yeah, one more thing. So is code important or not? I believe that is as important as value it creates. Thank you.
Thanks. You noticed switching from jQuery to React. Why Redux? Just now.
Okay,
why you do it?
Okay, so we started with React without Redux, I'll admit that, as a way to kind of render the state in a function-like way, right? But then we had a whole bunch of data being used from different places of the application. And we decided that the way to address that in a single storage, because that's what we actually had with Airtable and jQuery in the first place. We had a single storage, right? It was like in a variable that was cached to local storage and so on. So it was like natural way to grow towards Redux.
So it wasn't the question in first place. So you first switched to React, and then in some time you switched to Redux for a store. Yeah,
yeah, correct.
Oh, that's okay. Thanks.
Cool. Okay, next question. Thank you. So how do you quantify your tech debt?
Yeah, so that's a very good question. It's a vague problem, so to say. But there are tools that can help with that. And actually, we use Code Climate for that. So we get some metrics. They are not perfect, but metrics are like community-driven way to describe the good code, right? It's an attempt to do that, kind of. Okay, we might disagree, but this is something. It shows you trends. It doesn't show you like an absolute value if the code is good or not. It just gives you an idea and some basis to talk about it. It doesn't have to be like really correct, but it gives you the perspective that you can use to start discussing it within the team. And things that gets measured gets managed.
Okay, so at some point in your talk, you gave a number, 50K. How did you come up with this number?
Yeah, so that number comes from Code Climate, and they calculate it as they have metrics like how much time it takes to fix certain smells on per line basis. They have some certain factors like code duplication is easier to fix than, I don't know, conditional logic, for example, right? So they have some factors that they don't disclose, but behind all of that, it's an amount of hours to address certain issues. So they say that we need to spend like 3 months of that to fix all this tech debt to kind of get back to A score. Currently we have C. And then if we multiply it by standard rate, then we get 50K.
Okay, so how do you move the refactor intake tickets up the queue in the backlog? I've just checked. I had like 9 refactoring tickets in my backlog. One of them is 3 months old. The other one is 2 months old.
Yeah, welcome to the club. Yeah, so how we do it, not every tech debt it might be important, right? So when you need to work on something and it slows you down, then you can address that. So that's actually what happens during the grooming. So we look at what we are going to do feature-wise, and then we take the tickets that kind of are in the same place. That's why when we create tech debt tickets, we use feature components to understand where the change needs to happen. Also tech debt tickets to understand like who should do it, what kind of aspects technically it touches. And then we start with addressing that first so that we prepare for the change. So we make the change easy, and then we make the easy change, which is the feature to follow. Cool, thank you.
Okay, thank you. Next question, please.
Yeah, thank you for your talk. I think they were great ideas. and I'm trying to follow that more or less as well, and I can confirm it works pretty well.
Cool.
But what I think you didn't talk about much is how does your organization work? I don't think what you're doing is not going to work in, for example, an outsourcing situation or where you have lots of constraints. Could you talk a little bit more what your company is it? How is it owned, and how do you set long-term goals?
Okay, so our company is making shift from like external consultancy towards being a product studio. So we kind of grow our own products, and this is one example of that. So yeah, definitely it will work slightly different with external customers, but the principles will be the same. So because it's just code, right? So you need to be able to make the changes that are requested by the client. So it's a matter of kind of being able to convince the client that that makes sense. And if you believe it makes sense, you'll be able to convince the client as well. Because they want to avoid slowing down. They want to have sustainable pace, right, of development. And this can be only achieved when you kind of address tech debt at some point. And the best way to do it is to actually do it iteratively. So it's kind of more like a communication thing than process principle, I would say, because they are the same.